mercury vapor lamp is a type of high-intensity discharge (HID) lamp that produces light using an electric arc through vaporized mercury. They are known for being bright, long-lasting, and energy-efficient compared to incandescent bulbs, and are commonly used for outdoor lighting, like streetlights, and large industrial/commercial areas. How mercury vapor lamps work. The lamp contains a small fused quartz arc tube inside a larger outer glass bulb. This arc tube holds a tiny amount of liquid mercury and an inert gas, usually argon, and has two main electrodes and often a third starting electrode. 1. Starting the arc. When power and a high starting voltage provided by an external ballast are applied, an initial small arc forms between the starting electrode and the adjacent main electrode, ionizing the argon gas. 2. Vaporization and warm-up. The heat from this small argon arc causes the liquid mercury to vaporize into a gas. 3. Main arc strike. As the mercury vaporizes, the voltage is then able to ionize the mercury gas, striking a strong stable arc between the two main electrodes. This main arc is confined within the quartz tube. 4. Full output. The lamp takes 4 to 7 minutes to reach full light output as the mercury fully vaporizes, and the gas pressure and temperature inside the arc tube increase. The electric current excites the mercury atoms, causing them to emit ultraviolet UV light and some visible light, mainly blue and violet. The outer glass bulb often has a phosphor coating that absorbs the harmful UV light and re-emits it as a broader, more desirable white light, improving the lamp's color rendering. They also require a ballast to regulate the current once the main arc is established, as the lamp is a negative resistance device. Key characteristics. Light. Produces a characteristic bluish-white light, more white if phosphor-coated. Efficiency and life. Relatively efficient, 35 to 65 lumens watt, with a very long rated life, up to 24,000 hours. Restrike time. If power is momentarily lost, the lamp must cool down for 4 to 6 minutes before the pressure drops enough for the arc to restrike. UV danger. If the outer glass bulb breaks and the inner quartz tube continues to operate, it emits intense harmful UV radiation that can cause skin and eye damage. Self-extinguishing. T-type bulbs are designed to shut off if the outer bulb is breached. Environmental. They contain mercury and must be disposed of as universal waste according to regulations. Mercury vapor lamp cannot immediately restrike after a power interruption because the gas pressure inside the arc tube remains too high while the lamp is hot. Here's a breakdown. Paschen's law. The high pressure requires a very high breakdown voltage needed to start an arc, to re-ionize the gas. This voltage is far greater than the standard ballast can supply. Cool down. The lamp must cool down, typically 3 to 7 minutes, for the internal mercury vapor pressure to drop significantly. Once the pressure is low enough, the standard starting voltage from the ballast is sufficient to strike the arc again. Manual reset. Standard mercury vapor ballasts are not designed to automatically attempt a high voltage restrike. Flipping the power off and on forces the ballast to go through its cold start sequence once the lamp is cooled down, which is necessary to reignite the arc.